Okay, for today, we are just starting with a blank notability doc, and I am going to be teaching this the way I think it works best. This stuff is tricky that we're doing next because it's very abstract. All right. So, whenever I see a kid smiling and looking down at their hands, it usually means they're using their phone. This is the part where cell phones have to go away. I don't know if I even said it, but now I did. So put those cell phones away. If you have headphones in, please take them out at this time. All right, thank you. So, this is X. Label it so, because it's like going over in the X direction. The green one is Y, and I bet you know if I'm going to pick a number for the radius, that hypotenuse there, the easiest number I could probably pick would be 1, right? Wouldn't that be logical? And then I'm in what's called the unit circle, as in it's a circle that has a radius of 1. So far, does this all make sense of how I labeled it? All right, good. Now, do you remember that a squared plus b squared equals c squared? So don't even write it, but it's true, isn't it, that x squared plus y squared would be equal to 1 squared, right? So we need to make this about trig, so who knows what I'm going to do next? Replace the x and the y somehow, yes? Ooh, because x is really cosine. Everybody underneath x, write cosine, but cosine doesn't make any sense unless it's in the context of an angle. So this is the part where I want you to put a theta right there. So this is not cosine of x, it's cosine of theta. Do you get I can replace the x with cosine? And Jack, you know what I'm going to do next then, don't you? Replace the y with what? Sine. Yes. Sine of what? Because just sine by itself makes no sense. Sine of theta. There you go. Now this is important. On your test, if you write sine and you don't write theta or x or some angle, just this word, it doesn't make any sense. So if you write that as one of your answers, I have to mark it wrong. You have to have an angle there. Because just sine makes no sense. Sine of an angle, that can be a thing. All right, so make sure to do that. It's so easy. You'll catch me doing it too. I'll be writing a long thing out and I'll write sine and I'll forget to put an x there. All right. So then I think it's not too hard for you to see that sine squared, we usually start with sine for some reason. Now, wait a minute. Where you just put the squared like there instead of like, watch, I could have done this. Do you get why mathematicians have decided to put the squared inside there? Because you don't need the parentheses and it'll save some time. Let's talk about why they put it there versus on the theta. Is it really the angle squared? No. That's why it's not theta with the squared after it. The squared is on the inside and it means we're squaring the whole thing. It means this. But you put the squared on the inside. All right, so that's how you write sine squared. Plus cosine squared, and this time I don't have to explain it to you, is equal to 1. Now that is actually super powerful. It comes up on the ACT. I've seen it on the ACT. It's not gonna be as simple as just what's sine squared plus cosine squared. That's too easy. It'd be in the middle of another problem. And then you'd have to know that, oh, I can replace that with a 1. You know, they really are equal to 1. So wherever you see sine squared plus cosine squared, you can pull them out and put in a 1. So let me show you how that could be in a problem. Imagine a problem on your next test. This could absolutely be a problem on your next test. Sine squared theta plus cosine squared theta all over sine theta, and you'd have to be smart enough to go, oh, I know this one. That one's just 1. And so then this whole thing is equal to 1 over sine theta. And then somebody in here will be able to tell me what that's equal to. Come on, stretch a little bit. Go back into those files you've kept in your brain. The reciprocal of sine. Guarantee you there's 3 kids thinking it. Nate, any thoughts? Don't remember this one? Reciprocal of sine? Not cosine. Cosecant, you are correct. CSC. Do you remember that these are sister functions? Sine goes with cosecant. Cosine goes with secant. And tangent goes with cotangent. Do you remember those? Well, those come up in this unit too. So you've got to know this fact, that whenever you see 1 over sine, that you replace it with cosecant. So look at this crazy looking thing we started with. And look at how it just comes out to cosecant at the end. Because of substitutions. In the end, that's what it is. Do you get that if I have 5 $1 bills, which I don't, so let me see what I do. Here we go. I got a 10 and a 5 and 5 1s. Would you agree a 10, a 5, and 5 1s is a direct swap for a 20? So wherever that happens, like a 10, a 5, and 5 1s, you want to swap that for a 20, you can. And it's a lot simpler. Instead of like 5, 5, 6, 7 bills, I could just have 1. A 10, a 5, and 5 1s, or a 20. Well, you can swap them. So wherever you see something complicated like this in the problems today, you'll go like, is there something simple I can swap that for? And there is. It's just 1. Now, I'm going to give you a couple more that are example problems of what we're doing today. And then the thing that's best is to just do problems. You just kind of get used to these. At first, they can be really confusing. But then after you've seen enough of them, you start going, oh, this is actually not that hard. It starts out really confusing, ends up not that hard. All right, so here's another one that's just a fact I'm going to tell you. Everybody write this one down. Tangent of theta is really something over something, and there's somebody's going to remember it. I'm convinced that somebody can do this one. It's 2 trig functions. Yes. Because maybe you were thinking that it was y over r. You remember that deal? Or no, y over x for tangent was y over x, and y is sine, and cosine is x. Know what I mean? Tangent is y over x, and this is the y part. Y is sine, and x is cosine. You got to keep those together in your head, that y is sine, x is cosine. Okay, so then if you're in the middle of a problem like this, whenever I see that, I'm just thinking to myself, that could be sine over cosine if I want it to be. Times that's your problem, and you're like, what am I supposed to do with that? You are supposed to pull out things, put in other things, until you get it all simplified down, and usually your answer is just one thing. Like, that's equal to secant. So take a second. I just told you what that was. So do a substitution. It's like you take the 7 bills off the table and put down one of them. Take the tangent and put in this case, sine over cosine. And why is that good? Because something cancels. Okay, talk to the kid next to you. You should have got this down to 1 function, or at least 1 over a function.
Well, tan is like sine over cosine, and then cancel cosine, and then just do like sine. Would you have to like define
Right?
sine equals sine? Or like, I don't know.
All right. I know that you know this because I just told you sine over cosine is tangent. And then if all you could do is this, you do it, you know, like take the next step and you go, okay, now I'm going to look at that and see if there's anything I can do to make it easier. Riker, what makes it easier? Cancel the cosines. Doot doot. So the answer is just sine. And I said it would usually come down to just one thing, and that's my one thing. Cool. All right. Let's do another one. If tangent is sine over cosine, you should be able to use cotangent also. You should be able to use logic to figure out what that is. This one's tricky, but you can do it. It's all about swaps. I can pull out this and I can put in that. Okay, talk to that kid next to you about at least something you did to make it better. All right, cotangent. Well, I know tangent is sine over cosine, so this must be cosine over sine. How many of you caught that? If you didn't catch that, raise your hand if you caught that. Oh, it's like half. All right. Do you get that that's the flip of tangent? So you can take what tangent was and flip it. And once you got that, you should be thinking, I wonder if I can get this into something that's going to cancel with the other thing. And what is secant? That's the flip of, what's its sister function again? Cosine. And do you see how that works out pretty nice? Do. And now it's 1 over sine, which is basically saying I want the sister function for this. So what is 1 over sine equal to? Say it if you know it. Cosecant. And look at that. It's down to one thing at the end. Now, I am aware these are so abstract. Like, I can't draw you a picture of what's happening. I mean, there is actually a picture, but even the picture is really abstract of what these look like. And so it's a lot of just getting used to, like, what can you trade for what? Like, if I say sine, you have to be able to, like, what can I trade out for sine? Well, the number one thing you can trade out for sine is its sister function. So you could trade sine for a 1 over cosecant. All right. All right, this is the part where we're going to just jump right into the homework. And your homework is the evens on this worksheet. But what I'm going to do is go through and do some odds with you. So please do some odds with me. I'll do odd ones, and then your homework will be to just finish the evens. I think you'd agree we're getting into the homework really early. So that means, you know, I'm not going to sign the whole thing, but let's do some of the odd ones together. And then your job is to finish up the evens. So if we're still working on a problem and you want to go ahead, remember, your assignment is the evens. But I'll make you do a few odds with me too. Tully, would you read me number 1?
Cosine of x, and secant of x equals 1.
It just says that? Cosine x times secant x equals 1. Is that what the question says?
Yeah.
All right, then what does it say after that? I mean, what are the directions? It must say something.
Prove each of the following identities using reciprocal, quotient, and odd, even identities.
Okay, perfect. So they're telling me the answer is 1. That's kind of cool. I just got to show them how it actually comes out to 1. Do you know what I mean? It's like the ones I was giving you, I was just giving you this part, and I was saying to simplify it down. They're telling me it's going to simplify to 1. And so then you just have to show how that happens. So who sees it? But usually there's a kid who's like, I see it. You just got to replace this and this. Maybe you're not sure, but you think we should replace something. Just take a leap. Okay, I'll help. Secant is the sister function of what? Cosine. And cosine is the sister function of secant. So, somebody's probably already done it. Did anybody replace cosine with 1 over secant? Or the other way around, replace secant with 1 over cosine? All right. And then the cool part is, stuff cancels. That cancels that. And always end with a just fact statement. 1 equals 1. I know that seems dumb, but this is what's called a proof. Do you remember that you had some proofs in geometry? You had a couple proofs in higher algebra. Well, now you're in precalc. We have a few proofs. This is a proof. And proofs have rules. At the end, you have to have a statement of fact like 1 equals 1. And you can only mess with one side. I know this seems like dumb, but some people could have started by replacing the left side with this and the right side with, instead of 1, you could have put sine squared plus cosine squared. If you mess with both sides, you're breaking the rules of proofs. When you're proving something, you can only change one of the two sides. So you take the more complicated side and you change it until it equals the other side. Okay, so see how this stayed the same? You have to do that every time. You can't, one of your two sides, you got to leave it alone. The other side, you can keep changing until it is equal. All right. That was number 1. I'm sure by now somebody's probably started number 2. So I'll let you guys work on number 2 yourself. And there's an answer key, of course. Let's go on and show you a couple more. Number 3. Mason, would you please read me number 3?
Sine of x and secant of x
Times. If they're right next to each other, it means times.
times equals tangent of x.
Equals tangent of x. All right. So again, they told me the answer. That's kind of nice. Now I can just see how I could do some swaps here. I have a hint for you, and this is a good hint. If you can just think about changing everything into sines and cosines, then stuff will tend to cancel, and it works really good. So this is not a sine or a cosine, but I can change it into either a sine or a cosine. If it was tangent, I could even change it into sine over cosine. So pretty much everything can be changed into sines and cosines. So by now you should have figured out, oh, so you mean you should change this into 1 over cosine. And notice I'm just going to write equals tangent until that actually is equal to tangent. I'm just going to leave that right side alone. And now, these two together, I can put this over this. I would allow you to skip the part where you write it as sine over cosine, because can you see this is going to turn into sine over cosine? And I know that that is tangent. And there, I'm done before I even got to my last line there. Remember, the last line has to be a statement of fact, like this equals this. Some kids want to stop right here. I'm circling it in green. If you stop there, I have to mark it wrong. You haven't finished until you get to that red part. Okay. Now, there's one coming up where you would have no idea how to do it. Has anybody found it yet? Like, this is totally different than what you said. It has to do with odd-even identities. There's one coming. Which one is it? Problem number what? Garrett, do you see one? Okay, just keep going down until you see one that looks really weird.
7.
7. Mason, would you read me number 7?
Cosine of negative x
Yes. Keep going.
times secant
Oh, times secant of x. Keep going.
equals 1.
Equals 1. Well, it was nice of them to tell me what it equals, but I've never seen anything like that. Well, this is a good time to tell you that we are going to be giving you a sheet on your test of facts that are called identities. They're facts like sine is 1 over cosecant. We're going to give you a sheet full of that stuff. You don't have to memorize it all. We used to make people memorize it all. But then we decided that it is true that nowadays everybody has access to the internet all the time. If you were actually solving this question, you would probably go and look up a list of facts like that. And so we're just going to give you a list of facts like that. It's called the identity sheet. So would you please go out to Schoology right now and find the thing. It was a PDF that was called Trig Identities. I think I said shortened. Does that sound familiar? Okay. Find that one, open it up. Trig Identities shortened. On that list, there is cosine of negative x listed somewhere. Under odd evens. Would you read that to me?
Cosine of negative x equals cosine x.
This is off the sheet. Cosine of negative x is equal to what?
Cosine x.
That's a fact. I can show you why it's true, but for right now, I'm going to back up and do more of that tomorrow. Right now, I'm just saying this is a sheet of facts that you can use, and this is a true thing, that cosine of negative x is cosine of x. You know what, I'm just going to take a second, because I know there's a few kids in here who will be like, how is that true? Well, cosine of x would be like if I did this, and this is where the x variable is. I wish they were using thetas, but they're using x's. I'm going to switch it to theta. And if I did cosine of that angle, and I do cosine of negative the angle, it'll come out exactly the same. Let's say it was the 1, 2 square root of 3 triangle. Because cosine in this quadrant, where you do the positive angle or the negative angle, you're going to get the same exact thing because cosine doesn't use this side. So they're equal. Cosine of negative the angle or cosine regular the angle comes out to root 3 over 2. It's just true. So that is a fact that's off the sheet. So then I can replace, wherever I see cosine of negative the angle, I can put regular cosine. And secant, I recognize anytime they give you one of the weird ones, you know, the 3 that are not sine, cosine, or tangent, that you should change them into sine, cosine, or tangent. So secant can be changed into cosine, except it's not regular cosine. 1 over cosine. And then I can see from here that cosine times 1 over cosine will cancel, and it will be 1, but I have to write 1 equals 1. Did I follow my rules? Did I stay the same all on this side? Yes, I stayed the same on one side. Did I end with a fact? Yup. And did I show my work in between? There's the sandwich of work in there. That's how I grade these things at the end. And the hardest part is showing the work in there right. Because everybody can write 1 equals 1. Everybody knows they keep one side equal. But this work is sometimes messed up. All right, I think you got the idea. You guys are doing the evens, and you can refer to that sheet. I'm going to actually make physical copies of that sheet, like a paper copy. So I'll have that in the room so that if you, on the test, we'll give you that. Because you can't have your iPad out on the test, of course, so I'll be giving you the paper one. And that's all I have for today.